Look at the Snowflake platform architecture now. We will do an overview currently and then do a deep dive later. If you look at the diagram on this slide, you will see multiple concentric circles. Each circle represents a layer in Snowflake architecture. Beginning with the storage layer at the innermost circle. Now this is where Snowflake can store all types of data, be it structured, semi-structured or unstructured. This storage essentially comes from the object storage within the cloud provider. So when it is AWS, Snowflake is using S3. When it is Azure, Snowflake is using Azure Blob Store. When Snowflake is hosted on Google, Snowflake is using Google Cloud Storage. Since object storage is very economical and virtually infinitely scalable, that's the storage medium for storing all kinds of data. When it comes to the structured data, Snowflake also compresses and columnarizes that data automatically. It also creates smaller partitions called micropartitions automatically. Now Snowflake provides two choices for storing this data. One is its own native format in micropartitions and its own way of compressing and columnarizing. The other way is Iceberg open table formats, where the data is stored in Parquet files with Iceberg metadata and columnarized compressed in Iceberg open format. In case of Iceberg, the encryption can be done by bringing your own encryption key on the S3 buckets. In case of native Snowflake tables, Snowflake encrypts the data automatically. So this is the storage layer where data is stored in a optimized, efficient way, and it can be virtually infinite. Scale as much as you require. As more and more data comes in, this layer keeps expanding automatically. The second layer you see here is the elastic compute layer. This is representing the compute clusters for all the execution of workloads. Any kind of queries running on the data, any kind of machine learning program running on the data, this all comes from this elastic compute layer. We can have as many clusters as needed. They are very elastic in nature, so they can grow and shrink, start and stop very quickly. These computes can run multiple languages like SQL, Python, Java, and Scala. All of these compute clusters can work on the same data or different data as we want it to. Now, in addition to the compute clusters, Snowflake also has containers in this layer. These containers can be used to pretty much port any program, any application which can be containerized, right? So this could be ML programs, this could be applications written in C#, R, or any other languages. These containers also support CPUs and GPUs both. We can use GPUs for compute intensive work like maybe ML model training or running large language models for generative AI work. So you have very flexible compute option here. You can have CPUs, GPUs, compute virtual warehouses or containers for running different kind of workloads. The third layer you see here is the Cortex AI layer. Now this is specific to generative AI services which are available in serverless fashion. We can simply invoke the Cortex functions or applications to perform various Gen AI workloads. For example, translating natural languages to SQL queries, or running search services on top of unstructured data, or doing sentiment analysis or translation. All of these are Cortex services which can be invoked in a serverless fashion. Now under the hood there are LLMs available which are running in Snowflake. There are APIs which can be used for talking to these as if they are chatbots, and there is a studio for creating these LLM applications. The fourth layer you see outside here is the cloud services layer. This is responsible for metadata and management. Now this is the layer which is kind of brain of this whole platform. This maintains the connections from the clients. As there are connections coming to Snowflake, this layer is taking those connections and taking the requests and routing them to the right place. This layer also enforces security and governance. So we'll learn later about RBAC and multiple other things around security and governance. So this layer enforces that. This layer also keeps all the metadata about these objects sitting inside the platform. This metadata helps us optimize the query performance. This layer also optimizes the queries to run in a very efficient manner. So all of those activities under the hood are performed by cloud services layer. This layer ensures that we have to do very little work in terms of maintenance and management and tuning, and the platform takes care of all of those things automatically. The outermost layer you see here is SnowGrid. This is essentially required to connect Snowflake across different regions of globe. So we might have a Snowflake instance in Amazon sitting in India. We might have a Snowflake instance in Azure sitting in US, and then these can be connected to collaborate on data and applications. So this cross-region and cross-cloud connectivity is known as SnowGrid.